Hey there, Monday classes. This video is going to go through some examples and just pretend I'm here talking to you. Take some notes. If you get stuck on anything, feel free to pause the video, talk about it. Some of the people in class have asked questions, and so hopefully those questions will cover yours as well. And then once we're done going over those example problems, I have some practice for you. Now, we'll probably have a quiz next class. So, practice well. The answers to those problems are in the back of the book, and if you have any questions, I'll let you ask questions about those problems the next time I see you, whenever that will be. So enjoy, be nice, watch the video, and don't get scared. It's just trigonometry. You can do it. Okay. So here's the warm-up. Now, let's work some problems. So I want to work some problems where we're going to run into a lot of the common issues that we run into with simplifying these trig ratios. So one of the biggest things that we see are large, complicated fractions. And so we have this problem in the warm-up where we have to, say, find a common denominator, subtract the two things, and then maybe we would simplify from there. And it's not too hard when we have it in pretty familiar terms like 4x and 2x squared. Those don't look too bad. But when we have sines and cosines in there, it looks worse. It's not worse, but it looks worse, and it's intimidating. So what we want to practice with are doing some of these fraction things with sine and cosine, finding common denominators, things like that, eliminating fractions to be able to simplify things more easily. So a lot of what you see today is going to look scary, but you already know how to do it. So the key here is going to be, number one, familiarizing yourself with the identities so that it just makes it easier to do what you're trying to do. You don't have to think about it so hard. And number two, to learn not to be scared of it by practicing and by successfully completing some problems. And the more you practice it, the easier it will be. So let's start off with an example. And we're going to dive right in. We did some easier examples last class. We're jumping into the deep end. We're all in. Sink or swim. So here's the first problem. Sine of x times cosine of x over 1 minus sine of x minus 1 plus sine of x over cosine of x. Here's our problem. And of course, our directions on all of these will be to simplify. We're not trying to solve for x. We're not going to get an answer of x equals 3 or something like that. When we simplify, what do we want our final answer to look like? Do you remember? Yeah, a single trig ratio of some sort, and preferably with no fractions. That's going to be our goal. Obviously, we're not there yet. Okay, so generally our first step on any of these simplifications, unless you see something else to do, would be to turn all of your trig ratios into what? Yeah, sines and cosines. Okay, so let's do that. Okay, done. They're all already sines and cosines. So we don't need to do that. Next, we're just going to follow the directions that are encoded into the expression. What does the expression tell us we need to do? We need to subtract these two fractions. So I guess we should do that. Now when we subtract two fractions, we need to give them a common denominator, as previously discussed. So, let's think about what that common denominator would be. And I'll give you a hint. This 1 minus sine x, this whole thing is one factor. Okay, so treat it all as one piece. I'm going to put it in parentheses just to make that more clear. And so, what did you say, Hunter?
1 minus sin x, cosine x.
Right. So, if all else fails, you can find a common denominator, not necessarily the smallest common denominator, but a common denominator by just multiplying the two denominators together. That always works. So 1 minus sine of x times cosine of x. Unless these have something in common, which they don't, then we'll just multiply them together. This works because we can turn each denominator into that expression. So for the one on the left, what do we have to multiply this denominator by to get our common denominator? Yeah, by the cosine of x. So let's do that on the top and the bottom here. So we'll multiply by cosine of x and by cosine of x to the top and the bottom. Now, we already did it on the bottom. On the top, you notice you've got a cosine times a sine times a cosine. So we have one sine, and we have two cosines multiplied together. How do you write that? Cosine squared is correct. Okay, we got the left-hand side. Now on the right-hand side, what do we need to multiply this denominator by to get this one? 1 minus sine of x. Now, no. Well, look at what does happen. I'm going to go ahead and put the top in parentheses here because when I multiply these together, I've got two different expressions. How do I multiply two? These would be called binomials, right? Because they have two terms. How do I multiply two of those together? Do you remember what that's called?
Foil?
Yeah, distributing or foiling, which is essentially the same thing. Or, if you notice, this follows a pattern for a shortcut that we'll talk about in a second. But first I'm going to go ahead and just write it down like it is. This is 1 plus sine of x times 1 minus sine of x. Okay. So we said we could maybe foil this thing on the top. Or distribute, in other words. And so you can do that. Now this is actually one of those things called a difference of squares. A handy thing to notice because it lets you skip a little bit of the foiling step. So this is a plus b times a minus b. Does that ring a bell? Sure. I'm going to pretend you said yes. So this is one of those factoring situations. So those would multiply together to get a squared minus b squared. A difference of squares. You can still foil it, you'll get the same thing, but essentially what happens is the O and the I, the two middle terms, cancel each other out. So you get the first terms multiplied and the last terms multiplied. So that would be 1, that's the first two terms, and then the minus sine x, the plus sine x from the O and the I cancel each other out, and you get the last term, which is minus sine squared. So 1 minus sine squared. And I'm going to leave it in parentheses because it's one chunk of information. And then on the left-hand side, I have sine of x times cosine squared. And they're both over the common denominator, so when I combine those, I'm going to subtract the tops and put them over that new denominator. Like so. Okay? So there's my common denominator, and then I subtract the two top things. I just rewrote this one in a simpler form. Like so. So questions about that step right there? So I've gotten to this point. I followed the directions. I did what the expression told me to do. It said subtract, I subtracted. Now I get here. And it might not be as clear where to go. So once we get to a point like this, essentially what we want to do is look for substitutions we can make. And those substitutions are going to come from the identities. So even though you don't have to have all of the identities memorized per se, it is good to be familiar with them. So the first thing I notice when I look at this is this sign squared and this 1, and they're subtracted. And that reminds me of one of those identities that we talked about last class. The one where there's stuff squared and stuff added together. It is. And so this goes back to this Pythagorean identity. Sine squared plus cosine squared equals 1. This Pythagorean identity. And so if I rearrange this, like we talked about before, we said, okay, 1 minus sine squared would be the same thing as cosine squared. And so anytime you see a 1 and a sine squared or a cosine squared together with addition or subtraction, come back here, look at this identity, see if it can help you. Here it will. We said 1 minus sine of x squared would equal cosine squared, like so. So that's true. And we're going to make that replacement. Okay. And again, the more you do this, the easier that becomes. You'll build those relationships in your brain between this thing and that thing. The more you see them, the easier it'll be to see that. So we make that replacement, and now let's look at the top. So we want to try to reduce this fraction, because ultimately our goal is to write this with no fractions. And when you have some complicated expression like this, to reduce the fraction, remember we want to be able to reduce, like we talked about before, factors of the fraction. So on the top and on the bottom, we want to see if they have any factors in common. To do that, we have to factor the top and the bottom. Now the bottom is already factored. We're going to leave it like it is. So on the top, and I'm going to rewrite it. We want to try to factor the top. So do they have any common factors? That's the first thing to look at when you factor. Do the two terms have any factors in common? So perhaps you see they have something in common, right? That cosine squared. So what do I do with that common factor? Factor it out. So that would be cosine squared. I'm going to pull that common factor out to the side. And when I do that, what's going to be left over? So what would be left over for this term if I divide out the cosine squared? Yeah, just sine of x. And what would be left over for this term if I divide out a cosine squared? Yeah, minus 1. Now I have the top and the bottom factored. Once I have them factored, I can try and reduce the fraction. So now I'm going to look for things on the top and the bottom that cancel out. So do you see anything here on the top and the bottom that could cancel out? So you said cosine. Let's look at that first. We've got cosine to the first on the bottom, cosine squared on the top. So what happens there? Yeah, this cosine cancels out one of those cosines, leaving you with just cosine to the first on top. And we have these two very similar looking things. Sine of x, also, if you're confused, I accidentally added in a square there. That shouldn't be there. Okay. Let's try that again. Now these two things look very similar, don't they? Sine of x minus 1, that's a lot like 1 minus sine of x. Can we just cancel them out? They're almost the same. So what's the difference here? Right. So here, the 1 is being subtracted here, the sine of x is being subtracted. So essentially the difference is just the signs. On top, the SIGN signs. So on top, sine is positive and 1 is negative. On the bottom, 1 is positive and sine is negative. So how can I change the signs to make them match? Yeah, multiply by negative 1. So what I can do here is multiply this bottom part by negative 1, and I'll get, that'll change the signs, negative 1 plus sine of x, which is the same thing as sine of x minus 1. So they will cancel. I just have to change this one a little bit. So essentially they're negatives of each other. They have the opposite signs. And we ran into this when we dealt with rational functions as well, way back when. So like if you had x minus 2 and 2 minus x on the top and the bottom, they didn't quite cancel out. One of them is the negative of the other. So the same thing here. So we're left with just this lonely negative sign on the bottom. So a negative 1 essentially. All right. Does that make sense? This step trips people up sometimes. So just change the signs to make them match. Multiply by negative 1. And now we get here, and we're almost done. We can see the light at the end of the tunnel. Now, a negative on the bottom, we can just move that negative up to the top, right? Cosine divided by negative 1 is negative cosine of x. This is a trig ratio, a single trig ratio, without any fractions. Therefore, it should be simple enough. Okay? So out of this chaos, here comes this nice, simple answer.
When you had the sine x cos 2x minus cos 2x, and then you got rid of one of the cos 2x, how did you do that?
Right here.
Yeah, I'm like, I don't know how you got rid of one of those.
So since both of these terms on top have a cosine squared in them, they have a common factor. So like, for instance, if I had, let's say, 3y squared minus y squared, or something like that. What do these two things have in common? The y squared. And so if I wanted to, I could factor that y squared out. And then what would be left over? So here just a 3, and here just a minus 1.
Oh, okay.
And so that's essentially the same thing we do here. Look for whatever the common factor is and factor it out. And again, we see this theme. We're doing things that you know how to do, but they look worse because it says cosine instead of just like x or y or something like that. But we're using those same techniques. So that's what happened. Good question.
Thank you.
Okay, so like I said, we're jumping straight into the deep end of the pool today. So let's continue swimming around in the deep end of the pool. Here's another example where we run into some of these complicated fraction techniques. But again, things you know how to do. They just look worse because they say sine and cosine. Here's a problem. What's generally our first step on something like this? Usually we want to put everything in terms of sine and cosine, right? And why do we do that? Because I told you to?
Is this simple enough?
It can be. It gives us way to compare something like tangent and cosecant together, or something like that. Now here, we don't have sines and cosines, but everything is already written as the same trig function. They're all written as secants. So here, it actually wouldn't help to start off by changing everything to sine and cosine, because we really don't need to do that to compare these different quantities. They're all in the same terms already. So if we have a bunch of different trig ratios, we want to turn them into the same trig ratios, sine and cosine. But if we have a single trig ratio here, it really would only make this more complicated. This would be 1 over cosine, and this would be 1 over cosine, and 1 over cosine, etc. So in this case, we already have a single trig ratio. So don't replace it, at least not just yet. So let's look at what we have. We're given some very specific directions besides simplify. What are those directions? What does the problem tell us to do? Hint, it's right there. Yeah, subtract those two fractions. So, I guess we should do that. Now, to subtract two fractions, what do they have to have first? A common denominator. Now, these are similar. Are they the same? How can we make them the same? Or could we? Say, could we turn this one into that one, or vice versa? Could we turn this one into that one? How? So let's say we multiply by -1. Now, that would make secant negative, but that would also make the 1 negative too, right? So that wouldn't quite be the same. So it doesn't actually work here. What we want to do, the same thing we did on the last one, just treat this as one factor, one chunk of information for each one. They're different. And so to get our common denominator, we're just going to multiply them together. And recall, if you're not sure what to use as your common denominator, you can always just multiply the two denominators together. The same thing works with numbers as well. So this is going to be our common denominator here. Maybe it looks like a bad common denominator to use. It looks complicated, but it's actually going to work out really nicely, as you'll see. Once we know what our common denominator is, we need to ask ourselves, what do we have to multiply each side by to get that denominator? On the right side, what do we need to multiply the denominator by to get the common one? We already had this factor, so I guess we need to multiply by that factor, right? So we multiply by it on the bottom. That means we need to multiply the top by the same thing. So the secant of x, we need to multiply it by the 1 plus secant of x as well. On the right-hand side, we start off, we already have the 1 plus secant of x, so we need to multiply the top and the bottom by 1 minus secant of x to get the common denominator. So we multiply the bottom by 1 minus secant of x, we need to multiply the top by 1 minus secant of x as well. Okay, so far, essentially all we're doing is what the problem tells us to do. It says subtract, so we know we have to give them a common denominator, so we've done that. And now we're going to combine those two fractions together. And when we do, we're going to get this common denominator as our denominator. The one I said that looks ugly, but is going to work out really nicely. And on the top, we just subtract the top minus the top. And I'm going to go ahead and write it out like it is first, and then we'll go through and see what happens. we're distributing, never mind. I said I wasn't going to do that yet. Okay, we'll just write it down like it is. We get here. Okay, expression. We did what you told us to do. Now what? So you get to a point like this, and essentially we need to start simplifying again. So I just want to see what happens. And so you'll notice on top we have some multiplication, we have some subtraction, and so at this point we want to look at the top, we want to look at the bottom, see if there's any sort of simplification that we can do to each of those. So eventually we need to try and reduce this fraction. But first let's simplify the top and the bottom. So on top, we've got multiplication. We need to multiply secant by 1 plus secant, so we distribute there, of course. And we'll distribute on this side as well. So that's going to be secant of x. And secant of x times secant of x is what? Right, secant squared of x. Now here we want to be careful. When we distribute this secant on the right-hand side, notice it has a negative in front of it. We want to distribute that negative with the secant, so we keep our signs correct. So we're going to take a negative secant multiplied by 1. Which is, of course, just negative secant of x. And here, we're going to take the negative secant times this negative secant. And what happens to the negative signs? And we end up with secant times secant, which is, of course, secant squared. And you might already see some simplification that's going to happen on top. Now let's look at the bottom. We've got this thing times that thing. So we need to multiply them together. And what's the method you usually use to multiply two binomials together? Yeah, you can FOIL them. Now again, this is that special case of FOIL where the middle two terms actually cancel themselves out. This is a difference of squares. If you see that, that'll save you some time. So we're going to end up with 1 squared, which is 1, plus secant squared, minus secant squared, so those cancel out, minus secant squared of x. So you FOIL it, but the middle two terms cancel out. That's a difference of squares. 1 squared minus secant squared. Okay. So let's see if there's anything else we can do to simplify the top and the bottom. So same thing here. Do you see anything on the top that might, I don't know, cancel or combine? Maybe combine our like terms. So the secant, is there another like term with that one? Yeah. That secant. So what happens with a positive secant and a negative secant? Yeah, they cancel. And here we have secant squared plus secant squared. Those are like terms as well. What does that give us? Yeah, that would be 2 secant squared. And in case that doesn't make sense, let's pretend this was y squared plus y squared. All right. Of course, you know that would be 2y squared. So same idea here. Secant squared plus secant squared is 2 secant squared. Now we have this thing on the bottom. 1 minus secant squared. And anytime we see, say, a 1 and some trig ratio squared and they're added or subtracted together, our brain should jump to a particular place. And that place is on our identity chart. Okay. So let's look for an identity that might help us out here. these are the Pythagorean identities. So which one's got a secant squared in it?
The tan squared.
Yes, it is. This one does. And what did we have on the bottom of the fraction? 1 minus secant squared. So is there any way that we could rearrange this to get 1 minus secant squared? Okay. So let me write this on the same page. So we have 1 plus tangent squared equals secant squared. So you said subtract 1. We could do that. And that gives us secant squared minus 1, which is almost like 1 minus secant squared. So let's try it this way. Okay, so this is almost what we need. What's the difference between this and that? We saw something like this before. Right, so it's just the signs. How do we change the signs? Yeah, multiply through by negative 1. And we have to do that to both sides of the equation here. So that would be negative secant plus 1. Or in other words, 1 minus secant squared. These are the same thing. So what would this be equal to? Negative tangent squared. Do we need to look at that again? Just a little rearrangement here. And again, anytime you see a 1 and a trig ratio squared, and they're added or subtracted, or two trig ratios that are added or subtracted and they're both squared, think of the Pythagorean theorem. If you've got squared things added together, think Pythagorean identities. Okay, so there's our substitution there. 1 minus secant of x squared is the same thing as negative tangent squared. So we get here. Now we've pretty much simplified the top and the bottom on their own as much as we can. Now we want to combine them. So we could treat this as just a brand new problem. We get here. What do I have to do? I need to compare this secant to this tangent here. What would be a good way to do that? Right, I need to put them into similar terms. So here's where it's going to help me to replace each of those with their sine and cosine equivalents. So I get two different trig ratios that I need to compare. I need to put them in the same terms. So how does secant convert to sine or cosine? Yeah, it's 1 over cosine. And the same thing works with the square. It would be 1 over cosine squared. And since there's two of them, it's 2 over cosine squared. How does tangent convert to sine and cosine? Sine over cosine, and because it's squared, we can do sine squared over cosine squared. And because it's negative, we'll keep the negative sign. On the top, on the bottom, doesn't matter. And now we have a fraction divided by another fraction. What's an easier way to do that? We'll flip the bottom and multiply. So again, this negative can go on the top or the bottom, it doesn't matter. So we flip the bottom and multiply. And you see something's going to cancel here. Those cosine squareds. So we end up with negative 2 over sine squared of x. And we're almost done. So we got this to a single trig ratio, but there's still a fraction, right? So we have the sign on the bottom. That's like a 1 over sine. And what's 1 over sine equal to? Cosecant. So we're going to replace the 1 over sine squared with a cosecant squared. And there it is, the beautiful answer. From the chaos comes beauty. Okay. Let's try one more together. And then I'm going to make you try some.
Maybe some water.
Yes. It would help if you could see it. So this time we're going to start with 1 plus tangent squared divided by cosecant squared. And we want to try to simplify this. Ideas. That is an excellent idea. Let's put each of those in terms of sine and cosine and see what happens. Wait, no. I lied. Let's back up. That is not an excellent idea. Well, it is an excellent idea. But you might see right off the bat, you've got 1 plus tangent squared. Which means we should look at which class of identity? A Pythagorean one. So is 1 plus tangent squared equal to anything? Now, we could have converted this to sine and cosine, and it would have worked out and taken us about 4 extra steps. And that's okay. There's nothing wrong with practicing your algebra. But when you see a 1 and some trig ratio squared, something like that added together, you need to look at the Pythagorean identities. So 1 plus tangent squared equals secant squared. And the more familiar you are with those, the easier this will be. Okay, now let's convert it to sines and cosines. So secant squared would be what? 1 over cosine squared. And cosecant squared would be 1 over sine squared. A fraction divided by a fraction. What are you going to do? Okay. So we'll take 1 over cosine of squared of x times, and we'll flip this one, sine squared over 1. Or simply, multiply straight across, sine squared over cosine squared. Now this is one of our identities. We have it without the squareds. What's sine divided by cosine? Then sine squared divided by cosine squared would be tangent squared. So again, we could have started by switching to sine and cosine. It's always a good plan, but it's not always the best plan. So look for those identities. And part of what we want to do here is get familiar enough with those so that we recognize little bits and pieces. Say, oh, 1 plus tangent squared. That reminds me of something. Let me go back and look at that chart. Yes, it's secant squared. Okay. So now that you're all experts, I'm going to give you a chance to practice. And here's what I want you to work on. Now these problems are going to come from that orange textbook over there on the shelf. Specifically from page 317. And I'm doing this because I'm going to give you some odd numbered problems, which means you can check the answers in the back. so you know if you're doing it right. Okay, so we'll start off with a couple that were similar to some warm-up problems. So let's say 1 through 5. And by the way, these are all going to be odd. And then I want you to try some that are a little bit more complicated. So let's go with (23), 27, and 33, and 35. Okay? So grab a book, look at those problems. Again, the answers to these, I hope, are in the back. And if we run into some questions, we'll talk about those a little bit at the end of class. So now we practice. Practice makes better, if not perfect. Yes. Okay. So for those of you watching on video, we'll go over a couple questions at the end of class. So work on these for a little while. And if you have any questions, just put some marks next to them, and we can talk about them next time. Don't worry, I'm just talking to the computer right now. Y'all are good. Get to work.